So the next unit is unit circle, and the first section is going to be all about angles, but this time the angles will be on a coordinate plane. So the angle on a coordinate plane in standard form would have the initial side on the positive x-axis. So the first ray of the angle would be along there, and then if the angle is positive, it will rotate this way. And if the angle is negative, it would rotate this way. Coterminal angles are angles with the same terminal side. The terminal side would be the side that is not on the x-axis. So for our blue angle, it would be the blue ray. For the purple angle, it would be the ray in the second quadrant. So if you think about it, when you are on a coordinate plane, you can just keep rotating. So here's our initial side, our initial ray, and then you can just rotate all the way around, and this angle would be coterminal with my purple one. And then we have a reference angle, and that is the positive acute coterminal angle. So this angle would always land in the first quadrant, and we're going to see how those work a little bit later. Alright, so this is from the book, section 13.2, angles of rotation. Our objective is to calculate coterminal angles, reference angles, and we're also going to calculate trig functions of angles of rotation. So first we're going to take a look at just drawing an angle in standard position. So again, any angle on a coordinate plane in standard position would have its initial side on the x-axis. So that's where I'll start. And then a 450 degree angle. Well, I know one full circle is 360 degrees. So the first thing I would think is to figure out how many degrees past 360 are we going? And the answer is 90. So this angle would rotate all the way around plus an additional 90 degrees. And then it would have its terminal side on the y-axis. For a negative 200 degree angle, again, that initial side, we're going to make these in standard position, so our initial side will be on the x-axis. And this time we're rotating clockwise because it's negative. And 200 degrees is just a bit past 180, which is half a circle. So as I rotate, I'm coming up a little bit past my semicircle. Next, we're going to take a look at coterminal angles. So remember, these are just angles with the same terminal side, but maybe you rotated an extra rotation, 360 degrees, to get there. So when I'm looking at 720 degrees, I'm thinking two options. My first option, because this is so much more than one full rotation, is to subtract 360 degrees, and that would leave me with 360 degrees. So a 720 degree angle would be coterminal with a 360 degree angle. And if we think about sketching that out, here would be my 720 degree angle. Oops, I think I went too much past. I can't talk and write at the same time. So there's 360 degrees, 720 degrees. And the terminal side would end up being the same as the initial side. My 360 degree angle, on the other hand, again, starting on the x-axis, rotating one full rotation instead of two full rotations. So those would have the same terminal side. So there's one with a positive angle measure. So to get one with a negative angle measure, I'm thinking, okay, well, it's one full rotation. So what if I rotated counterclockwise instead? I have several options, negative 360 degrees, negative 720 degrees, that would be two rotations, and so on. For my negative 30 degree angle, I'm a visual person, so I like to draw pictures so I can see what I'm looking at. So here's my initial side. My negative 30 degree angle would be rotating into the fourth quadrant. So to get a positive angle, I would think about, well, how much do I have to rotate this way to land in the same spot? So I would take 360 minus the 30 degrees, and my positive coterminal angle would be 330 degrees. And I can just rotate a full rotation plus another 30 degrees to get my negative coterminal angle. So thinking about my initial angle, if I did one full rotation clockwise, and then another 30 degrees, that would give me a negative 390 degree angle. Our next objective is looking at reference angles. Remember, the reference angle will be the angle in the first quadrant that is kind of the same distance from the x-axis as this one. So let me show you what that means. And because I like to draw, I'm going to give myself a little bit more room here. Alright, so the first thing I'm going to do is set up my 345 degree angle. So I'm rotating counterclockwise because it's positive, and it would get me not quite back to the x-axis for the full 360 degree rotation. I'd be just shy. So what we have to think about is reflecting that back up into the first quadrant. So the degree of rotation below the x-axis will be the same amount as the degree of rotation above the x-axis. Well, I'm 15 degrees away from a full rotation, so this would be a 15 degree angle. That would be my reference angle. For B, we're taking a look at a negative angle. So sketching this one out, negative 130 degrees would be more than the 90 degree angle, but not a full semicircle. So I would land here somewhere. Again, the negative angle rotates clockwise. So there's a couple of different ways to think about this one. You could reflect it twice, once up into the second quadrant and then over into the first quadrant. Or you could just think about how far away from the x-axis you are. Well, to get my full semicircle, I would need 180 degrees, so I'm 50 degrees shy of the x-axis. So reflecting that over into the first quadrant would be a 50 degree angle. In our last example, we're going to be looking at finding trig values, all 6 trig functions. So I think the first thing I want to do is remind you, we briefly covered the 6 trig functions earlier as to what those other 3 trig functions are. So you guys should be familiar with sine, cosine, and tangent. And then the other 3 trig functions were reciprocals of these 3. And the secant and cosecant are backwards. Cosecant sounds like it should be the reciprocal of cosine, but it's actually the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So this example, if we set up this point on our coordinate plane, so I've got 5, -3, so it would be about here. And then what I would do is draw the right triangle that would get me to this point. So my x coordinate was 5, so the length of my leg here is 5. My y coordinate was -3, so this length will be -3, and we have to find the length of our hypotenuse in order to set up the trig functions. So the first thing I'm going to do is Pythagorean theorem. So we've got leg squared plus leg squared equals hypotenuse squared. 5 squared gives us 25, plus 9 gives us 34. So our hypotenuse would be the square root of 34, which doesn't simplify. And then we use SOHCAHTOA to set up the original 3 trig functions, and then just flip them to set up the other 3. And theta, remember, is the symbol for an angle. And when you're looking at the angle, it would be the angle made with the origin and the hypotenuse. So sine of theta, looking at opposite over hypotenuse, we would have -3 over the square root of 34. Rationalizing that by multiplying by square root of 34 over the square root of 34 gives us -3 square root of 34 over 34. Cosine will be adjacent, so 5 over hypotenuse, square root of 34. Rationalizing it the same way, we end up with 5 square root of 34 over 34. And tangent, opposite opposite over adjacent, we get -3/5. So for our new trig functions, cosecant, remember, is the reciprocal of sine. So if I take my original ratio and flip it, I'm going to get a rationalized fraction. Same thing for secant, reciprocal of cosine. So I'm going to take my original ratio and flip it, square root of 3/5. And then cotangent is the reciprocal of tangent, -5/3.